Tonight's Moment of Geek is all about measurements. For instance, this tease took approximately 7.4 seconds and burned approximately 4 calories. Metrology rules. Tonight's Moment of Geek celebrates the very core of all scientific endeavors. Happy World Metrology Day! Metrology is the science of measurements, measuring anything: weight, distance, time, temperature, force, resistance. There's probably even a way to measure how closely this giant party hat parallels my big nose. Metrology is what allows two different people, even if they're in different places or different times, to know that they are talking about the exact same thing. As Scottish mathematician Lord Kelvin once put it, quote, "When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind." Lord Kelvin should know he had a whole temperature scale named after him. You want to know what happens when metrology fails? How about this? In 1999, NASA lost a Mars orbiter when it missed its target. Why? A measurement mix-up. A data table listing how much the orbiter's thrusters would make the spacecraft spin was calculated using the metric system. But the scientists who interpreted the numbers used a whole different system. They used the English system to interpret them. Newtons, not pounds of force, you idiot! I can personally attest to a more terrestrial need for metrology: bartending. Bartenders who believe in free pouring, who believe you can just eyeball an ounce of liquid, you're wrong. I know you think you're right, you're very experienced, you went to bartending school, speed pours and the whole thing. I'm counting. Yeah, you know what? You're wrong. Free pouring leads to imprecise drinks. They will vary every time you make them. You have one of these, or a jigger. Use it. So today, scientists around the world are celebrating an event that happened more than a century ago. On this day in 1875, representatives of 17 nations signed a treaty called the Convention of the Meter in Paris. It created the International Bureau of Weights and Measures. The Bureau still exists. It's where they keep the 118-year-old metal cylinder that is used as the reference for the kilogram. Seriously, could there be a cooler job than keeper of the kilogram? Actually, there might be one. How about Chief of Time and Frequency? Joining us now to celebrate World Metrology Day is Tom O'Brien, who is Chief of the Time and Frequency Division at the National Institute of Standards and Technology. Tom O'Brien, thank you very much for joining us. It's really nice to have you here.
It's great to be here on World Metrology Day.
So, I know you say your most accurate clock is accurate to 1 second within 3.5 billion years, but how do you know that?
That's a very good question. Metrology, or the science of measurement, is very challenging. So mostly we try to compare it to other clocks that we think are nearly as good or close to being as good. But there's always a chance for making an error, and you gave some examples of where errors can lead you.
I understand there was also a pretty good example of a failure of metrology from the Baltimore Fire Department.
That's a failure of standards which are related to measurements. Back in 1907, there was an enormous fire in Baltimore, and as the Baltimore City people tried to put out the fire, they called in fire departments from across the region. Unfortunately, the fire hydrants in Baltimore were using a different standard for mating the fire hoses than those from Washington, D.C. and Philadelphia and the other areas. So when the firefighters arrived to try to put out the fire, they couldn't use their equipment. And that was one of the things that led to people trying to develop a system of standards across the country for not just fire hydrants, but for all kinds of technology.
In reading about World Metrology Day today, which I spent way too much time doing, I was fascinated to learn that scientists mostly use light now to measure distances, including from the distance from the Earth to the Moon. How do you do that?
Well, it used to be that the distance was the length of a bar of metal kept at the International Bureau of Weights and Measures. But then in the 1970s, people found out that they could make a more accurate measurement by measuring the time it takes for light traveling at 186,000 miles in a second to travel a certain distance. And in the Apollo 11 mission, the first manned mission to the moon, one of the instruments that they took up there was something called a retroreflector, which just takes light and sends it right back. So shining a laser from the Earth, bouncing it off that retroreflector, that mirror on the moon, and timing how long it takes to get back to the Earth, enables the scientists to make really accurate measurements of that distance. So accurate, in fact, that they can see over time that the moon is moving away from the Earth on the average of about 1.5 inches per year. And there'd be no other way to measure that except by through a laser.
I know that there aren't any Nobel Prizes in metrology. What makes scientists want to go into the field, aside from the fact that it's obviously cool to talk about on cable TV, which I'm sure you do all the time?
Well, I'm sure that's the main. I'm sure that's the main motivation. But actually, while there isn't a Nobel Prize for metrology per se, a very large number of the Nobel Prizes have been awarded for outstanding measurements, including 3 Nobel Prizes since 1997 to scientists from NIST, where I work, for helping to develop things like the technology behind atomic clocks and cooling atoms with lasers and so on. So while metrology might sound kind of dull and kind of boring, in fact, pushing the boundaries, making measurements at the real edge of where you can do, requires you to bring all the resources of science and technology to bear. So some of the most interesting science really comes about by trying to push back those boundaries of measurements.
Do the scientists at the National Institute of Standards and Technology sit around in the lunchroom talking about how you guys could totally measure the rate of flow of that oil leak if they just let you at it? It's totally measurable?
That's a really hard problem, and I have a lot of sympathy for people who are trying to make a very difficult measurement a mile down under the sea without being able to directly interrogate it. So no, we're not second-guessing that at all.
Tom O'Brien, Chief of Time and Frequency at the National Institute of Standards and Measures. Thank you very much for your time in helping us celebrate World Metrology Day. Thank you for your time. I mean that in every way. You know what I mean? Thank you, sir.
Thanks a lot, Rachel. Great to talk to you.
That was so cool.